Hello guys, welcome to my channel. In this video, we will discuss the DC machine problem of the book Parker Smith. So let's start. So the DC machine problem number 14 from the book we have taken here. The question is saying a shunt machine connected to a 250 volt mains has an armature resistance including brushes of 0.12 ohm and the resistances of the field circuit is 100 ohm. Find the ratio of the speed as generator to the speed as motor, the line current in each case being 80 ampere. So it has given all the resistances and it is saying find the ratio of the speed as generator to the motor if the line current is 80 ampere. So let's understand the question more. So you can see here this is the circuit of a DC shunt machine. So this is shunt field and this is the armature, and you can see this is the load part. So you can see the terminal voltage is 250 volt here. So V is equal to 250 volt, and you can see it is for generator. I have drawn the diagram. So the armature current is moving like this away from the armature or away from the machine, because in generator the generator supplies the current, but in case of motor consumes the current. So in generator this is the circuit and it has given 100 ohm as the shunt field and 0.12 ohm as the armature resistances. So it is saying if line current is 80 ampere, what is the ratio of the speed as generator to the motor? So we have to calculate speed for separately generator and motor. So let's move forward. So if RSH is or shunt resistance is 100 ohm, we can calculate ISH as 250 volt divided by 100 ohm equal to 2.5 ampere. We can say here this ISH here is 2.5 ampere. As generator circuit, if you consider the generator circuit, the armature current always moves away from the DC machine or the generator like this. So if you apply KCL at this node point, so IA will be the sum of IL and ISH. IA is the sum of IL and ISH if you consider these directions of the currents. So IA will be 80 plus 2.5, 2.5 is calculated here. So IA will be 82.5 ampere. And we know for the generator this is the equation of voltage E equal to V plus IAR. So EG will be calculated like this 250 plus 82.5 into 0.12. This is the current value and this is the resistance value which is given in the question. So you can finally calculate the value of EG for the generator. So let's see what is the next part. Similarly, we can calculate for the motor. As you can see here, if this is the motor, we know that motor consumes electric power, or it takes the current. So we take it as IA and the direction is towards the motor, and the shunt field current is like this, ISH towards this, and the load current is like this in this direction. So you can say IA equal to IL minus ISH, which is the difference between the currents IL and ISH. So we can calculate here IA as 80 minus 2.5, 77.5 ampere, and this is the voltage equation for motor, EB equal to V minus IA RA. So finally you can calculate EB as 240.7 volt. So we know that in case of DC machine, this is the formula for generated EMF, E equal to P5 Zn by 60A. So you can say E is proportional to speed, or N. So you can write as Eg by Eb equal to N1 by N2, where N1 is the speed of generator and N2 is the speed of motor. So we have already calculated the values of Eg and Eb. So if you put the values of Eg and Eb here, you can calculate the ratio of N1 and N2, which will be 1.08. This is the answer. You can see here answer is also given 1.08. So you can say the generator rotates a little bit faster than the motor. So how we solve this problem? We first try to find out the IA values for generator and motor separately. Then we applied the formulas for generator as V equal to E minus IAR, or E equal to V plus IAR, which is for generator, and for motor we applied E equal to V minus IAR. Then we took this is EG and this is EB. Then we took the ratio EG divided by EB, which is nothing but N1 by N2, because E is proportional to N. This is how we calculate the ratio of speeds of the two machines, of the DC generator and motor. So that's all for today. If you enjoyed it, drop a like below and don't forget to subscribe.